Welcome back to Topic 6 for Algebra 2, Relations and Functions. In Part 2, we're going to learn specifically about the domain and range and how to write it in both interval notation as well as inequality notation. Let's first review if a relation is a function or not, what we learned in Part 1. In our example here, we are asked to rewrite the relation in the given mapping diagram as a scatter plot. Recall that in the mapping diagram, we have our x's on the left and our y's on the right. So the x's, these are our x coordinates, and the y's are our y coordinates. If we were to plot this on a graph, we have -1, -2, so over -1, down -2, over 1, down 1, over 1, up 0, over 2, up 0, over 2, up 2, and over 3, up 2. So here's our scatter plot. Now, is this relation, is it a function? If we look at our graph, we know that 1 goes to -1 and 1 goes to 0. So on our mapping, we see that -1 repeats. On our graph, we can also see that we can draw a vertical line through these points right here, and it would hit it more than once, so it would fail the vertical line test. So this relation is not a function. Let's move to number 2. Here we have a scatter plot and we have to write it as a mapping diagram. So again, let's have our x's on the left and our y's on the right. When you look at the scatter plot, I really want you to focus on the coordinates. So our first point, we have over -2. That's going to the y coordinate of -3. We have our -2 goes to a y coordinate of 0 as well. We have a x coordinate of -1 goes to a y coordinate of +1. We have an x coordinate of 0 goes to a y coordinate of -2. And we have a x coordinate of 1 goes to a y coordinate of 1. So this relation is not a function because if we look at our graph here, we can draw a vertical line and it would hit our graph more than once. We can also look at our mapping because we have -2 goes to -3 as well as to 0. In number 3 here, we have a table and we're asked to write it in a mapping diagram. So we have our x's on the left, our y's on the right. If I notice in my table, we have our x's of 1 and 1 actually repeat. So keep that in mind when translating that to the mapping diagram. I like to go with my x's in my mapping diagram from the smallest to the largest. So I notice I have a -3 first, and that goes to a -1. Then I notice I have a 0, and that goes to a +3. Then I have a 1, and that goes to both a -2. And 1 also goes to 0. Then I have a 2, and that goes to 2. So this is not a function because we have +1 goes to -2 and +1 goes to 0, so it repeats. We also saw that in the table format. Last but not least, we're asked to rewrite the relation in a scatter plot as a set of ordered pairs. So in terms of a set of ordered pairs, really we want to write the coordinates of these points. So we have -3, 0 for our first point. Then we have -2, -3. -1, +1, 2, 0, and 1, -1. This is a function because we have no x values that repeat, and if we look at our scatter plot, we can draw a vertical line and it would only hit a point once. Now with a set of ordered pairs, oftentimes we have our kind of curly brackets. Unfortunately, because I wrote a little bit too large, these are not in a complete row, but keep that in mind, we keep them in a curly bracket. Now let's move along to the domain and range. Keep in mind that our domain deals with all of our x values and our range deals with all of our y values. Now we use parentheses or strictly less than or strictly greater than when dealing with an open circle on our graph, or when we see that the graph goes to infinity and it goes off of the page. We use brackets or less than or equal to or greater than or equal to when we deal with a closed circle or point and a solid line or curve, or we see a circle and it's complete. Now whenever we use a parentheses or a bracket, this is called interval notation. And then whenever we have our inequalities, this is obviously called inequality notation. So for our first few examples, we're going to identify the domain, range, and if it's a function or not in both inequality notation as well as interval notation. In our first example here, we have the domain. Now we want to look at our x's. So horizontally, how far does our graph go? On the left-hand side, the smallest point is -2. And on the right-hand side, the largest point is +2. Now, because we have an open circle at -2, we're going to have a parentheses and a bracket at the +2 because it's a closed circle. Now, if we want to write this in inequality notation, think of these -2 and 2 as our boundaries. So we have -2 is less than x, less than or equal to +2. Again, less than or equal to matches with brackets, and then the less than matches with the parentheses. Now with range, let's see if I can make this a little bigger. There we go. Now with range, we're looking with our y values. So we're looking up and down. The lowest possible point that we have is -2, and again, open circle, so we're going to have our parentheses. The highest point that we have is +1, closed circle, so it's going to be a bracket. If we want to write this in inequality notation, we have -2 is less than y, because we're dealing with our range here. Y is the range, is less than or equal to 1. Now, is this a function? Does it pass the vertical line test? Yes, it does. Moving on to our example here, we have a circle. Again, our domain is all of our x values horizontally. The smallest value that we have is a -3, and the largest value that we have is a +1. Since this is a solid curve or a closed circle, we're going to use brackets. If we want to write it in inequality notation, we have -3 is less than or equal to x, less than or equal to 1. Again, those -3 and 1 are our smaller and larger boundary numbers. For range, we're dealing with the height of the circle. So since it's a circle, we start at -1, we use our brackets, and goes to positive 3, also use our brackets. If we want to write this in inequality notation, negative 1 is less than or equal to y, less than or equal to 3. However, is this a function? Does it pass the vertical line test? I can draw a vertical line and it hits my graph more than once, so it is not a function. Number 7, we have an example here. Again, domain is our x values. So if we look all the way to the left, we have a negative 2. All the way to the right, we have a positive 2. Since they're both open circles, then we have parentheses. In inequality notation, we have negative 2 is less than x, which is less than positive 2. For the range, we're looking at our y values. We go all the way down to negative 4. Again, this is a solid curve here. So we're going to have a bracket all the way up to 0. Also a bracket there because we have a solid curve. So even though we have these open circles, they are not the highest and lowest point of our graph. So we are not using them to determine if we have a parentheses or if we have brackets. In inequality notation, we have negative 4 is less than or equal to y, which is less than or equal to 0. Is it a function? It passes the vertical line test, so it is. Moving along to our next example. Here we're asked to identify the domain range and then evaluate each function for the given value of x. So here, remember, this is using our ordered pairs, which were represented in part 1 of our relations and functions video. So the domain is all of our x values. So specifically, we have 10, negative 2, 5, and 4. We're just listing them. And then our range is all of our y values, 7, 4, 3, and 10. Now we're asked to evaluate the given value. This is really our value for x. So we have f of x, or when x equals 10. So we want to look at our point when x equals 10, which is right here. What is that y value? That y value is 7. Moving along to the next example, our domain is our x values. So we're going to list, we have negative 3, negative 1, 0, and 1. And then our range is our y values, 3, 1, and 0. Notice how the 1 repeats, but I don't need to write it more than once because it's included in the range. And then when f is negative 1, we're going to scroll over, see what our y value is. Our y value is positive 1. For this example, we have a mapping. Remember, our x's are on, the left, y values are on the right. Our domain is all of our x values, which in this case is negative 3, negative 1, 1, and 2. And our range is all of our y values, negative 2, negative 1, and 0. F of negative 3 is when x equals negative 3. What value is our output? It's negative 1 if we look at our mapping, so negative 1. For our next example, we have a scatter plot here. Now our domain, since it's just points, we're just going to list all of the x values. We have negative 2, 0, 1, and 3. These are all of the x coordinates. And the range is our y coordinates. We have negative 1, 0, 1, and 2. Now when f is 3, we want to look on our graph. What is our y value? Our y value is 0. For number 12, we have a half circle here. Our domain, again, is all of our x values. So we go from -3 to +8. I'm sorry, that was our, goodness. Our domain is all of our x values. I was confusing our range with it. So we go from 0 to +8, and since we have an closed circle at 0, we're going to have a bracket, but we have an open circle at 8, so we have parentheses. If we write it in interval notation, we have 0 is less than or equal to x, which is less than 8. Our range is all of our y values, which, there we go. The lowest value is -3. Again, we're looking from top to bottom. The highest possible point is right here. At 1, we have a solid curve and a solid point at those respective places. And our inequality notation is -3 is less than or equal to y, which is less than or equal to 1. When f is 0, what is our y value on the graph? When f is 0, if we look at that 0 point and then rise or fall until we hit our graph, that y value is -3. So this is where it falls on the graph. Few more examples to go. With this example here, our domain, the smallest possible value all the way to the left, is 0, and since we have a closed circle, we're going to use a bracket. However, on the right, if we were to zoom off, it actually goes off the graph. So this is going to go until infinity. Since infinity is not defined, it's indefinite, we are going to use our parentheses here. If we want to write this in inequality notation, we have 0 is less than or equal to x, which is less than infinity. For our range, again, that's all the way from the lowest possible point to the highest point. We have -3, it's on our curve, so we're going to use a bracket. All the way up to infinity goes off the page, which is a parentheses. So this is -3 is less than or equal to y, which is less than infinity. When f is 4, when f of x is, when our x is 4, goodness. When x is 4, we want to look on our graph and find where on the graph that would be. That would be right here on our graph when y is 1. Okay, last few examples. Here we have this curve. If we look all the way to the left and all the way to the right for our domain, it goes off the page. So our domain is actually from -infinity to +infinity. So in inequality notation, we have -infinity is less than x, which is less than +infinity. Our range also goes off the graph for the bottom portion. So we have -infinity, and the top part is 4 is the highest part. That 4 is a solid curve, so we're going to use a bracket. And for inequality notation, we would use -infinity is less than y, which is less than or equal to 4. When x is -3, so f of -3, we're going to look on our graph, find our -3, go up or down until we hit the graph, which is at our y value of 1. Our next graph, we have this kind of W graph. Our domain is all of our x values, which in this case, all the way to the left and all the way to the right, is -infinity to +infinity. So again, our inequality notation is -infinity is less than x, which is less than +infinity. Our range is our lowest possible number to our highest possible number in terms of height. Our lowest possible number is -6, and we have a solid line there. But the highest possible value goes up and up towards +infinity, so we have a parentheses there. our inequality would be -6 is less than or equal to y, which is less than positive infinity. F of 2, when x is 2, we're going to find positive 2, go down until we get -4. Last but not least, our final problem here, our domain, all the way to the left and all the way to the right, if we were to zoom out, it would actually go from -infinity to positive infinity. So inequality notation, we have -infinity is less than x, which is less than positive infinity. For our range, our lowest possible value and our highest possible value, also -infinity to positive infinity with our parentheses. Inequality notation, we have -infinity is less than y, which is less than positive infinity. When f of -2, when x is -2, right here we know that our y value is 0. That was topic 6 for Algebra 2, Part 2. Thank you for watching.